Hello. Now we are going to start a tutorial session or training session for the foundation coaching from spectropy. This is Mr. Krishna, Physics SME from spectropy. Let us start a brief discussion and introduction about mechanics. First of all, coming to the subject wise, physics. Physics is broadly categorized into five different modules. The first one is mechanics, which deals with the study of motion of an object, and electromagnetics, which deals with the study of electrical and magnetic effects, and then thermal physics, and then optics, and finally modern physics. So these five divisions will explain clearly about entire physics. So the study of physics again broadly divided into the five major categories. Among them, the first one, mechanics, we are going to start today. What is meant by mechanics? Mechanics is again study about movement of an object. When can we say an object is moving? When we know whether it is at rest or in motion, or whether its position is changing or not, or whether its location is being translated or changed or not. So being with that, we come to know whether the object is moving or not. So basically the mechanics definition can be taken in this way. The branch of physics which deals with the study of moving objects or effects, causes, etc. Again, in mechanics, we have again two categories. The first one is, see, when the object is moving or not, how can we know whether its position is changing or not? Suppose if I want to know the mechanics of stationary object like this, the study of the stationary objects is statics. Similarly, the study about the moving objects can be called as dynamics. So again, mechanics is broadly divided into statics and dynamics. To understand better about rest and motion, first of all, the state of the object is again two types, rest and motion. Again, to understand better about the rest and motion, let us take an activity. In this activity, let us consider two characters. One is Mammu, another one is Chinnu. Here, this Chinnu character is observing Mammu. Now, what is the state of the Mammu when observed by Chinnu? Here, once observe, and whenever there is a question arises in physics, we should be getting any one thought-provoking idea or questionnaire or prompt. Here, whether any object, whether it is at rest or motion, how can we decide? By a simple question. Is there any change in the position of object or not? Who is object here? Mammu. Who is observer here? Chinnu. So, is there any change in the position of the Mammu or not? We should observe. If you observe Mammu is at rest only, the position is not changing at all. So we can say no for this question. Answer is no. As there is no change in the position of the Mammu, we can say she is said to be at rest. Now, Chinnu is observing different object, school bus. Here school bus is moving forward and backward. Again the similar kind of the question. What is the state of the bus, school bus, when observed by Chinnu? Again the same kind of thought-provoking question. Is there any change in the position of the school bus or not? Here, if you observe, there is change in the position of the school bus when you observe it is continuously moving forward and backward. So I can say, as there is change in the position of the object, so it is said to be in motion. Chinnu is observing bus now. So what is the state of the bus when observed by Chinnu? Again the same thought-provoking prompt, which is there any change in the position of the school bus or not? Yes, there is change in the position of the school bus continuously. So we can say, as there is change in the position of the bus is said to be in motion with respect to Chinnu. So this is a brief introduction about rest and motion. And for the exam point of view, let us take the definition for the rest as well as the definition for the motion. If a particle position is changing or never changes with respect to particular position or time, it is said to be at rest. If the position is changing continuously, it is said to be in motion. Simple. Now, the next topic, we should understand whether you are able to identify any situation, rest or motion. For that, we have taken a concept connector. Here the first situation is walking. Walking means, let us take an idea here. Here this gentleman is walking. Here if you observe, the position of these fellows who are walking continuously changing. So as there is the change in the position of these persons or these characters which are involved in this illustration, we can say they are said to be in motion. So walking should be coming under motion. Now the next situation is sleeping. And this sleeping activity, again let us consider an object or a character which is sleeping here. You see here our favorite character cat is sleeping deeply. But if you observe, while sleeping the position never changes. So it must come under rest. The next activity is dancing. Again, dancing, you always know, dancing means definitely we must move. So here the position of the dancer also being changes continuously. So we can say the dancing will come under motion. Now, next activity is playing. Playing any play like outdoor games like volleyball or cricket, whichever you take, the playing involves the movement. So there must be movement, that is why it will come under motion. Next activity is standing. Standing is, the title itself indicates it is constant position, standing. You can observe here, this character is standing but remaining all are moving. Now this position is the same position, never changes, that is why she is said to be at rest. So it will come under rest. The next situation is statue. Statue, you all know, statue always constant, the same position, any landmark. Now coming to the ball throwing, next activity. The ball throwing, let us consider a toddler here. If you want to throw a ball, you must take the ball and you must move it like this, right? You can see here in this a short video. So this, the bowler, the person who is throwing the ball as well ball also, the both are in motion. They both are changing the position. So ball throwing must be coming under motion. Now last activity is cycling. Cycling, you all are getting experienced day-to-day life. Cycling, it involves the continuous movement, right? So that is why cycling comes under motion. So my dear students, I hope you have understood about rest and motion, and also we have discussed one concept connector. Now it is time to go to the next major topic of today's session, that is types of motion. There are different kinds of the observations and day-to-day life surrounding us, different kinds of the movements. So let us discuss one by one among them. Let me take a ball here and let us move it. Yeah, okay. So this is our object of interest and it is moving continuously along a line or along a path. Whenever an object is moving along a path, along a line, we say that is translatory motion. Similarly, let us consider this. A car is moving along a certain path. Now you observe the path resembles certain geometry. Which geometry you all know, you have completed your geometry topic last up to 5th class or 6th class. This is circular path. So the object which moves in the circular path, the kind of the motion is called circular motion. It's very simple. The path is circular, so circular motion. Now the example for this is satellite movement. The motion of the satellite around the earth can be considered as circular motion, but not the earth, be careful. Okay, similarly let us consider one more, our favorite comfort zone at home, and it is most usual electrical appliance which we can observe at our home. When you switch on, definitely this fan will rotate like this. Here if you observe, each and every part of the wing is in circular motion. But what is the difference here? Earlier case, the total body in the circular motion and the radius also almost all same. But here the edge of the wing is different radius, but here this part is different radius. And they are all moving around a fixed line, and that fixed line is called axis of the rotation. Now, this kind of the motion where there will be motion of the body around a fixed line, it is called rotatory motion. But again, we will be getting confusion, right? A similar kind of confusion. Let's check so. Now, let us do a simple activity, rotate ball. There will be rotation something like this. Here if you observe, there is continuous rotation around a fixed line. If you take a line here, it looks like rotating around this one. So we can say this kind of the motion also rotatory motion, but the main important is most of the aspirants getting confusion. It is what is the difference between circular and rotatory. To understand that in a better way, let us try to watch a video here. Here if you observe motion along the circumference of the circle, the path itself is the circular path. It is circular motion. But the motion of an object around a fixed line, it also looks like circular, but the axis of the rotation is passing through the object in this case. It is called rotation. So this is the main difference between the circular and rotatory motion. Yes. Now, the next very important phenomena is study about the to and fro motion of object. So let us consider here a ceiling and then hook, and it is called point of suspension. And from here let us suspend one which we call bob. Along with a string, let us suspend a bob. When I move it gently, then it will move forward and again come backward. So the to and fro motion of an object something like this is called oscillatory motion. So in oscillatory motion, the beauty is it is a repetitive motion also, and it is to and fro motion. If you take any particular point, around the same point, the object move once in this direction and then come back in the same direction. About a fixed point, if you observe, about any point, you take one point here, you observe, there will be to and fro motion, and it is oscillatory motion. And other classifications of the motion are, we can classify based on the repetition, like periodic and non-periodic. Just now oscillatory motion we observe that is periodic motion, and random motion where there is no pattern, particular pattern, and based on the dimension. Dimension is again whether it is moving along only one direction, it is one dimension. If it is moving along two directions, it is two dimension motion. If it is moving along three directions, that is three dimension motion. So it is about the other kind of the classification of the motion. Now let us try to understand. Periodic motion, right? One of the first thing I told you just now, in the case of simple pendulum, there is continuous movement, right? Like periodic motion, it is moving this direction and again going that direction and again coming back. It is repeating its path. So these kind of the motions which repeat its path, they are called periodic motion. And even we can consider random motion is like they move randomly, something like football player. Football player, there is no particular structure based on opponent and based on the ball movement, he has to move randomly. So this is the particular category and classification of the types of the motion. Whereas one dimension motion, you all know, moving only along the one direction. Here the train is moving along the straight track, that is only one direction, so it is one dimension. Similarly, an object thrown upward, something like this, and it is also moving only one direction, it is one dimension. Whereas coming to two dimension, something like this, a cricket ball moving, here it is covering both y direction as well as the x direction. Once again you can observe here, it is moving like this, right? So it is covering one direction, it is covering second direction, upward also it is moving. So it is two dimension projectile motion. Whereas three dimension is something like this kite movement, it is moving x, y as well as the z upward also. So here one dimension, two dimension and three dimension, this is the classification according to the direction of the movement. And we have come to the end of the session. The definition for the kinematics. See, the study about motion of an object without considering what causes its motion. That means without considering the cause. And also what happened because of this motion, effect. So the study of the motion of an object without considering cause and effect is called kinematics. And in kinematics, we discuss about different things like object properties. What is the position, what is the change in position as a displacement, what is velocity, change in velocity as acceleration, as well as first equation of motion, second equation of motion, different things we discuss in the coming sessions. And for all these discussions in kinematics, we consider every object as point object. What is meant by point object? If any object size is very less when compared to the distance it travel, the size of the object very small when compared to the distance it travel, then it is considered as the point object. So in kinematics we consider point object only. And the last topic of today's session is reference frame. What is reference frame? To understand this in a better way, let us take a situation here. Suppose this is a guest house and you are enjoying your music here. Let us consider our object of interest here, Ferrari car. Now, while enjoying, you are observing this object and this object start moving slowly here. So this is a road or ground or a space where the motion of object is being observed. What happened here? The motion of this object is being observed, and this setup or this platform is called reference frame. Again we can formulate the definition. Reference frame is a platform where motion of object is being observed. Simple. And if you want, you can even fix the timer also for the better understanding. Yes. And the object from where you are taking reference is called reference point or origin in the case of coordinate geometry. So it's all about the reference frame. So dear students, I hope you have understood about this rest, motion and also types of motion. We will continue the discussion again from next session onwards and the next upcoming topics. Thank you.